Hello, my students. Let us proceed with our today presentations. And remember, we are still under wave descriptions. But lucky enough today, we are in the last part, which is wave velocity. We are under the last description of a wave, which is called wave velocity. Now, to begin with, let us define what is a wave velocity. A wave velocity is the distance covered by a wave in 1 second in a specified direction. The distance covered by a wave in 1 second in a specified direction is called wave velocity. I think you remember in Form 2 you learned about velocity in the topic of Newton's law. Therefore, here is the same thing. Velocity, as we know, distance over time. But here we are talking about wave velocity. That's why we're including the term wave. It's the distance covered by a wave. Why? Because we are talking about wave velocity. The distance covered by a wave in 1 second in a specified direction is called wave velocity. That is how simple it is. Now, after there, this is to say, let us assume this is the wave. This is the wave traveling from this point, going this way, going this way, going this way, going this way. If at all this is 1 second you are talking about, and now this is the distance, you must measure the distance covered by this wave in 1 second. In recording wave velocity, we are looking about the time taken by a wave velocity is 1 second. 1 second. Now, if at all here distance maybe is 10 meter. Now, what would be our wave velocity? You take 10 meter, you divide by 1 second. Now, what is our wave velocity? 10 meter per second. Now, this is what we talk about wave velocity. The distance covered by wave in a specified direction, but in a specified direction in 1 second is called wave velocity. This is not very difficult. Now let us assume we have the time for more than a second. For more than a second. That means our wave took a time which is more than a second to travel from one point to another. How can we go like with this one? Remember, for you to get wave velocity for more than a second, we are going to mathematical operation, which is saying wave velocity is nothing but the distance covered by that wave, you divide by the time. Now remember here, time is not second. Therefore, you divide by time taken by that wave to complete that distance. This is how we can go to wave velocity. But I think you remember about what is velocity, distance over time. Therefore, this part is not very, very difficult to you. Therefore, this is to say velocity, which is given by capital letter V, is nothing but distance you divide by what? You divide by time. Another thing to note under velocity is, remember, under frequency we said frequency is the constant value. Frequency is constant value. Remember this one, because it depends on the source, not the media. But wavelength is not constant. Why? Because this one depends on the media. Today also we have wave velocity. This is also not constant. Therefore, wave velocity is changing as the wave moves from one media to another media. If the wave is moving from air to maybe water, wave velocity in air, if it's V1, wave velocity in water, if it is V2, therefore wave velocity V1 is not the same as V2. Why? Because wave velocity is not constant, because it depends on the what? Medium, not on the source. This is what we should note about wave what? Velocity. Another thing to note under wave velocity is wave velocity is denoted by, if you want to denote or to represent wave velocity, denoted by capital letter V. We normally use the capital letter V to denote wave velocity. But another thing to note here is the SI unit of wave velocity. Remember, we said wave velocity is nothing but distance over time. Distance over time. Now, for us to get SI unit of wave velocity, we should go to what is the SI unit of distance? Meter. Therefore, this is meter. What is the SI unit of time? Second. Therefore, what is the SI unit of wave velocity? Meter per second. You can also represent as here, meter per second, like this way. I think this part is not very difficult to you. Now, we have another thing, which is now we want to know as wave velocity concern. This is all about relationship between wave velocity, which is V, wavelength, which is given by lambda, and frequency, which is given by f. We want to see how these three quantities are related. Now, for you to understand how these three quantities are related, consider this illustration here. This illustration will tell us how frequency, wavelength, and wave velocity are related. Now look under this diagram. I have assumed that this wave travel only a one complete cycle from point O to point A. But also I have assumed that under this diagram I have located both the distance and time for this wave covered. The distance covered by this wave and the time covered by this wave. Although this is not possible, but we assume that for this x-axis to have the quantity of distance and the quantity of what? Of time. If this is the case, what will be the quantities from point O to A? What will be the quantities from point O to A? Remember, we are discussing the relationship between frequency, wavelength, and wave velocity. We want to know. We must use this figure here to know how they relate. Now, when you see from point O to A, this is a one complete cycle. And in x-axis, we have both distance and time. Now, if we assume this x-axis is now distance, is now what? Distance. The distance covered by a one complete cycle is nothing but a what? A wavelength. Therefore, from this point, we can have what? Wavelength. If this, we assume now, this x-axis is represented by time, the time taken for a complete cycle, we call it what? Period. Therefore, don't worry. That's why you can see this is wavelength. We assume that now this is in distance, and this is period, which is t. We assume this is now in what? In time. After understanding these ones, now let us go to see how wave velocity, and frequency relate. Let us go back to relationship from wave velocity. Do you remember wave velocity? Yes. V is nothing but distance over time. Do you remember this one? Yes. But do you see our figure? This figure is talking about one complete cycle. Now, assume for one complete cycle, for one complete cycle, for one complete what? For one complete cycle, what are we going to have? Our x will not be x again, but will be what? Wavelengths. Because the distance covered for one complete cycle is called wavelengths. Our t will not remain to be t again, but will be what? Period, time period. Because the time taken for a complete one cycle is called what? Period. Now after here, let us substitute this value to this formula here. What are we going to get? We are going to get that wave velocity, which is v, will be equals to x. But what is x for one complete cycle? Wavelengths, my students. And what is over t? What is t for one complete cycle? Time period. Yes, time period. Now we have another very good formula, another interesting formula, which is saying v is now equals to lambda over t. This formula, those who know mathematics very well, they can write it as this way: lambda times 1 over t. Do you see this one? Lambda times 1 over t is the same as this one. But do you remember what is 1 over t? 1 over t is nothing but frequency. 1 over t is nothing but what? Frequency. Now, how can we say v will be equals to lambda times 1 over t? Our 1 over t is what? Frequency. Therefore, the relationship between wave velocity, lambda, and frequency is v equals to lambda times f. This equation is called general wave equation. General wave equation is saying wave velocity is nothing but the product of wavelength and frequency. Did you see how these three factors are relating? Yes, they're relating by this equation, v equals to lambda f. But all the way you have passed, I think you have understood until you have reached here. At this point, let us go to another note. Do you remember what you have discussed earlier? We discussed that as wave concerned, frequency is constant. V and lambda are not constant. They are depending on the medium. Now, let us recall wave equation. Wave equation is said how? V equals to lambda f. Now let us make f the subject. F will be equals to v over lambda. If this is the case, let us assume this is equation 1. Assume we have two different media. For two different media. For two different what? Media. For two different media, f will be equals to v1 over lambda 1. Let us assume this is the first media. But also f will be equals to v2 over lambda 2. Let us assume this is the second what? Media. Because for the two different medium, frequency remain the what? The same. But what changing is velocity. Velocity, it was v1, now is v2. Lambda 1, now is lambda 2. Let us assume this is equation star 1 and this is equation star 2. If you look through this equation, we can go to mathematical operation as follows. Do you see these two equations? Yes, are relating because both of them frequency equal to. Now equate equation 1 and 2. You'll find that for the two different media, our equation will be v1 of lambda 1 is nothing but v2 over lambda 2. This is another equation which you are going to use it in attempting difference questions as as wave velocity concerned. Now, up to that point, my students, let us have a short break. Thereafter, we are going to finish up with examples.